for each loops. You saw this momentarily as enhanced for loops, and they're in some ways smarter than regular for loops, but kind of give you less control. So they're called enhanced because they eliminate out-of-bounds exceptions, but you can't do anything. But it's quite specific in how they work. They access and process through elements versus in regular for loops. You can kind of play around with the indices and all that. So code-wise, it's easier to code but harder to understand. If you're familiar with Python for loops, then you are familiar with for each loops. It was added back in 2004, and they added it to the AP exam in 2008. It's good to know that you can use for each loops with arrays and array lists. Here's an example of what they look like. Compared to a normal for loop, we have an array of strings, right? There's our classic apple, banana, coconut, durian, fig. And here is your standard for loop that would print each of them out. You have your start, your stop, and your increment. Should be muscle memory by now, writing down for loops. Here's your for each loop on how it works. Notice you have the declaration that matches the elements, type, string, s-word, a colon, and then you have the name of your array or array list. And then you're printing out s-word. So one step at a time, s-word takes the place of each element. It's apple, prints out banana, then coconut, then durian, then fig. S-word is the element at each of these positions inside s-words, or sa-words. No indices stuff. Direct access to those elements. So this slide explains what's going on. One by one, each element of the array is copied into that variable s-word. Note that the types must match. If the array is an array of strings, then the for each loop needs a string variable to copy the elements into it. So that's making sure these two keywords match. If it were integers, then this would be an int, and now over here it would be an int. Booleans, so on and so forth. Okay, notice the use of the colon too. Did we ever use the colon in Java so far? I don't think so. I think this is the first instance where we actually use the colon as meaning something special. Colon with two periods, not the semicolon with the comma. So here's another example. You have an array of integers printing out with your standard for loop. Notice how it uses the indices and the square brackets with this array of integers. Here's the for each loop version. The for keyword still remains, and then inside parentheses int temp. This matches the type of array that you have, and it's an array of integers. Don't forget your colon. And here's the name of your array or array list. Notice no use of square brackets occurs here. Ntemp is 45, and then it turns into 67, turns into -2, 17, 23, so on and so forth. Okay, some more examples of how this for each loop works. Here is an array list called a bunch of words. We've added dog, cat, bird, and rat into it, and using a for loop, we'd use the .get member function of array lists to access each element to print out dog, cat, bird, rat in that order from this array list. A bit more code. Shouldn't be that surprising given that you've done some FRQs related to array lists. They're fresh in your head. Here's the for each loop version. Notice this first part stays the same. Okay, and the for each really looks like almost just like the for loop version. For, and then you have string that matches the type of array list you have. SAnimal is your temporary variable. It's the one getting printed. It holds each element. Then you have your name of your array list. So not too surprising. At most, it's 1, 2, 3, 4 new things you have to pay attention to when working with for each loops. And so some things to keep in mind about style. You never need to use a for each loop. A for loop does everything that a for each loop can do. And as a rule of thumb, you only use a for each loop whenever you need to access every element in an array or array list in order. And here's the kicker: without replacing or removing any elements. Use a normal for loop in all other cases. This is the one case where it becomes useful. I guess it saves you like a couple clicks of the keyboard, or if you're writing code by hand, a couple words by hand. It will come up though when you're in the multiple choice portion. The College Board will give you for each loop questions, but you're not expected to write for each loops in your FRQs. You can just stick with for loops and you'll be fine. Just be able to read and understand what a for each loop is asking you, and you'll be in a good spot. So for you to get some practice, we have a for each loop worksheet due this Friday. Answers are posted on the website, so free points. If you have questions on specific things, do ask. Our next our next synchronous class, or email me and I can explain it further. To test our understanding, I don't think we'll have time. So we have a couple more slides that we'll skip over. If you do want to look over this and see what's up, then go ahead, but I think you can answer that on your own. We're going to pause here. Questions on for each loops? None? All right, back to more AP exam review. Scroll down to where we roughly left off. Okay, so we did this. And then we go talk about more miscellaneous things related to the AP exam. You'll likely see some of these ideas appear in the multiple choice that we're giving you this week and next week. I think pacing-wise, when you're working on the multiple choice, it's roughly 2 minutes a question. If you split it evenly amongst your hour and 30 minutes, I think it was 40 multiple choice, is your full-length exam. But the practice we give you, the College Board only released partial exams and stuff. All right. So as we're working with multiple choice section, there are some tips and tricks to make your thinking easier, right? Some speed techniques, I guess. So one thing is to remember distributing the exclamation mark. You remember back when we worked with Boolean logic, the exclamation mark means not. So this by itself reads true or false. Not true or false is the same as not true and not false. If you want to be fancy, this is De Morgan's law. It's the distributive property with the not operator. I think that's the right word. And it can go, so that could save you some time. As you know, when working with ands, there's this short-circuiting relationship that's present. false and true, when you immediately see false, you know that the overall statement, this AND statement, is false. And I believe that short-circuiting idea the College Board does make use of. Let's say you had like an error somewhere after the AND symbols, and there was a false out in front. That code doesn't even bother running. It just sees a false, and then it returns false as this overall AND statement's output. So, more examples of that distribution. It also works with ANDs and ORs. Notice that if A, B, and C are Booleans, you have A and the quantity B or C. This is the same as A and B or A and C. In one of these cases, maybe it's easier for you to evaluate said logic in that manner. Same thing here, you can distribute the OR. A or B and C is the same as A or B and A or C. Evaluate it how you will. Some small but useful reminders. Double check the time, doing okay. And then, particularly, knowing that idea of opposites and distributing the AND, like when you're writing else if or else and if statements, you could make use of this logic. I know there was a multiple choice question that made use of this, like which one is equivalent, select from the following, something like that. So the opposite of less than is greater than or equal to. Oftentimes we forget about the equal to parts when thinking about these opposites in terms of inequalities, so be careful. Here's an example of it. Not nx being less than 3, okay? So if you're not less than 3, that's the same as saying your variable nx is greater than or equal to 3. Pretty standard stuff, but often in the rush of things we forget. Okay. So quick reminders on Boolean logic. You remind yourselves of those symbols. Maybe we haven't used ands, ors, and nots in a while. The idea of distribution may come in handy when they ask you which statements are equivalent. Any questions? Boolean logic? Does it sound familiar? I guess you need to see some questions to be sure. All right. Thanks. Next up, like out of your 4 types of FRQs, yeah? There was array lists and arrays, there was methods and control structures, which is kind of like the miscellaneous category. Boolean logic will kind of fall there, math-related questions. Your third category of FRQs, those topics you're guaranteed. You have class design that we worked with last week with Frog Simulator, Random String Chooser, and Step Tracker. And then the last topic that you're guaranteed to have on FRQs was 2D arrays, and often they're paired with nested loops. That FRQ you worked on during the Game of Life or Minesweeper. We had the nested loops worksheet. That's the last topic. I think we review that the least, since you just need to. I think I want to review more on objects, but like it's hard because I can just tell you all these things, but you need to like put them into practice. Perhaps prioritize the object-related FRQs. Email me so I can like make some slides and discuss those further. I feel like objects are kind of the harder ones out of everything because it's been a while since we worked with them. So I plan to, but give me some more things to work with. I can also ask Mr. Simon what more stuff you have with objects. 2D arrays, I feel like you'd be okay with after seeing a couple of slides. Or even, like, since it's an online AP exam, have a cheat sheet of 2D array stuff like right next to you, so you can look at it like, oh, this is how I did my neighbor stuff in Game of Life. The indices work like this: rows and columns, blah blah blah. I can't really enforce a paper cheat sheet being next to you, right? So some reminders on 2D arrays. Think about 2D arrays as an array of arrays. If we had the alphabet, this example should look familiar. Notice that alphabet, this array, has a length of 4, and it has indices 0, 1, 2, and 3. Alphabet, the element at index 0 inside the alphabet array is an array. The element at index 3 is the shortest array out of the other, compared to all the others inside the alphabet array. As you think about working and like maybe printing out the entire alphabet out of this 2D array, you would first start with a loop. But notice if we just had one loop, it would just go through each of the rows. Okay. If you tried to print this out, I think it would print out memory locations, not the letters that you expected. So we need to enlist the help of another loop that goes into each of those inner arrays to print out the individual characters. That's why we have the green loop here. The yellow represent the rows, the individual arrays. The green loop, or the inner loop, represents the columns. Those are its individual elements. Notice the difference here, right? Here's that array, then you go inside each array, access each element, so that you can print out, or so you can know how many elements are inside. I misspoke. Then this is like the funny syntax, right? I think about them like coordinates. Alphabet, square bracket R for the row that you're at, then column. Rows, then columns. Rows, then columns. It's like domain and range, X and Y. Rows and columns, rows and columns. Rows go left and right, columns go up and down. Inner loop, outer loop, rows and columns. Since we talked about for each loops, there's the for each loop variant. Don't recommend you do this, because often with 2D arrays, you're so used to index manipulation, messing with the R variable or messing with the C variable, that I think at this point, giving you for each loop just might end up being more confusing. But maybe you'll feel different after the for each loop worksheet. More power to you. If you write broken code, then you risk it on EarthRQ. You're comfortable with for loops, so I recommend you stay there. Okay. This thing is called the course description, and it's a big binder. I think I have a copy of it somewhere in my room. It tells you everything you need to know about the AP exam. It's publicly available online as a big PDF. Your teachers, like I was reading it for a while and then I got bored, but if you wanted to read the whole thing and understand everything that's in there, then you'd be super prepared for the AP exam. The important part is on page 119, or 191, there is the most up-to-date example of multiple choice questions. Remember that the standards change from year to year, and so some questions get dropped or others get added. That's why this 2020 AP course description, the 15 multiple choice that we've assigned you for this week, are the most accurate representation of what you'll be given this year in the AP exam. Start with those. And in a way to make sure you're doing these multiple choice questions, I think at the end they give you the solution key anyways, so no need to like cheat, you're just cheating yourself. As you work on it, use this little multiple choice recorder to write down your answers. I think even the best of us will make a couple of mistakes on there. I'm asking that you reflect on the mistakes that you made and kind of explain your initial thought process, what you learned from like a given question. That's the Google Doc that I shared with you this morning. Give it like a paragraph is like 3 sentences minimum. So write and use my example that I have with this bonus multiple choice question I found somewhere to guide what you need to write. Ideally, if everyone messed up on a question, then I could copy and paste that and make like one big study guide for you all to share and kind of review collectively between my 2 blocks. So then if you got that question wrong, you could go look at someone's response of, oh, they made the same mistake I did. They probably made or had the misconception that blah, 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 blah. Like in my example, I wrote that I forgot that remove fills in the array list, the remove function. Yeah, so even the slide has the answers to it. So emphasis there is for you to get the practice. Some reminders is pacing-wise, roughly 2 minutes each, so you should be spending like 30 minutes on these 15 multiple choice. And I think that's it for today. So you get to go 3 minutes early. You're welcome to stay if you have other questions. Take care. Monday we have short classes. Bye-bye.
Bye, Mr. Chen.
See you later.
Thank you, Mr. Chen.